Hey there, Mustangs. Welcome to another edition of No Here, No Problem. Rosenwald here talking about Chapter 4 applications, which is dealing with the graphs of sinusoidal functions. What I would describe this as is if you've ever been into like an escape room and you have to kind of take little bits and pieces of the puzzle and kind of figure out what it is that's happening. Well, that's what's happening with these applications is what we're looking for are patterns that take place, little details that we'll notice, and we're going to use that to kind of figure out some other information. When we look at a sinusoidal function, we're looking at a wave that's taking place, and when we look at the wave, there's like this top part and there's this bottom part, right? There's this max and there's this min. In addition, we're looking for certain graph features. So, for example, when I look at a graph, this is what a sine curve looks like, and then its reflection is a negative sine curve, right? If I was to look at a cosine curve, this is what the cosine curve looks like, and then this is what the reflection of it looks like is an upside down like bell curve. Okay, so we're going to be looking for bits and pieces of information, and we're going to be stringing these together to go ahead and put together some equations, some functions, if you will, that we can use to kind of graph it, get a line of best fit, and use it to analyze some potential future data. Okay, so that's all we're going to be doing. So let's kind of get started here. All right. So first, let me get myself out of the way as always. All right, so to start us off here, let's take a look at this first function here. We're looking at a cosine curve, and the first question is asking us what's the maximum and what's the minimum, okay? Well, we know that our cosine curve typically goes up to 1 and -1 for the range, and what's happening is we have an a value here that's going to cause a vertical stretch to take place. So what that means is that I'm going to take this, I'm going to vertically stretch it by 2. That means we're going to take every one of these values and we're going to multiply them by 2. So if I multiply each one of these by 2, these are the new values that we're going to get. Now, when it says the max is the highest point, the minimum is the lowest point, so the max is at 2, and the minimum is at -2. And the middle value, that 0, if I multiply it by 2, doesn't change. Okay? Let's talk about the next one, -3 sine of pi x. We're again looking at the max and the min for this one. Sine's max and min still also is at 1 and -1. But what's happening is we have an a value of -3. So that means that we're going to take our values and we're going to multiply everything by 3, but it's going to be a reflection that's going to take place. So the graph would actually end up looking like this. But again, the max and the min are these two spots right here. Those are going to happen at 3 and -3. All right, so now let's take some information and kind of piece together an actual function, okay? So it says construct a sinusoid with a period of pi over 5 and an amplitude of 6 that goes through 2, 0. When they say a sinusoid, they're talking about this function right here, that y is equal to a times the sine b x minus c plus d. But that's not the only one. We can actually replace this word with the word cosine, and that's another sinusoid function. It's the same function, it's just shifted by pi over 5 typically, okay? So when we are given information, we're going to piece together the a, the b, the c, the d value, and then we're going to go ahead and put them into the function to get an overall equation. Some of this is very easy. For example, the amplitude is 6. Well, that's easy. That's our a value that happens to be in our problem. When we say it goes to the point 2, 0, what we're actually saying is that the graph has been shifted to the right 2 and it goes up 0. So when we say a point 2, 0, we're forcing it to go to the right 2. So let me show you what that actually looks like just to confirm it with you, okay? I'm going to pull up my Desmos here. And we're going to go ahead and open up our sinusoidal function here. Give me 1 second. Okay, now I'm going to take this graph. If we look at the graph right here, we got this spot at 0, 0. I'm going to take it, I'm going to shift it to the right to 2, 0. And watch what I'm going to change. The C value changes here. You see that? I'm moving this side to side. And when I move to the right to 2, 0, you can see that my graph has shifted to the right 2, moved to the right 2 here, and then it moved up 0. And that's got the point that we need. Okay? So that's my C and my D value taking place there. Now the period is usually the hardest part, but it's really not too bad. All right, the period is pi over 5. What we should remember is that the period of any sine function is going to be 2 pi divided by whatever the b value is. Well, we're told that the period of this is pi over 5. So we're going to say that 2 pi over b is equal to pi over 5. If we take and cross multiply here, we're going to get 10 pi is equal to b pi. If I divide by pi, we get that our b value is equal to 10. So if we put all this information together, let's string all this into our equation here. We're going to put in our A, our B, our C, and our D values here. Just pull them straight from the equation. We have 6 sine of 10, x minus 2 plus 0. That's just putting in our A, B, C, D value. Now that 0 that's there, I don't really need it. So we can also just say y equals 6 sine 10, x minus 2. You could have even gone so far as to multiply it out and said 6 sine 10x minus 20 if you wanted to, just by distributing that 10 there, okay? All right, let's continue. So same idea. We're going to go ahead and piece things together. You can see we have a whole bunch of blank spots here, but all we're going to do is we're going to kind of piece together some information, okay? It says we're going to construct a sinusoid that rises from a minimum at 2, 0, or I'm sorry, at y is equal to 2 and x is equal to 0, and it goes to a maximum of y is equal to 6 and x is equal to 6. So think about what they're giving me here. They are giving me a coordinate at 0, 2, and they're saying that this is a minimum value, and it's going to rise from this minimum value. So what that means is that I'm going to start down here at 2. I'm going to start all the way down at 2 for the y value, okay? And for the x value, I'm going to start at 0. So this is a coordinate that I just plotted. I applied the coordinate 0, 2. 0 to the right, 2 up. The next coordinate that we have is going to be at 6, 6. What this says is that my graph is going to rise from 0, 2 and go up to 6, 6. So it's going to start here at 0, 2, and it's going to rise up and then go back down, right? That's going to be a max and a min that they're giving me, okay? And so think about what that gives me. That gives me this value right here because it's rising. I'm sorry, this value right here because it's rising up to 6, and it's going over to 6. So there are my coordinates, 6 and 6. Now we could piece together a whole bunch of information from this. You ready? We can figure out what the middle of this is to get that midline right here, okay? That middle is the average of these two numbers, the 6 and the 2. If I do 6 plus 2 and divide it by 2 to get the average or the midpoint, that's going to give me a value of 4. That's my D value. My graph typically is at 0, right? It's normally at 0, but it's now been shifted up 4. So now I know that my D value is equal to 4. The amplitude is the distance between these two values. So 6 minus 4 means that I went up 2. And then I go down 2. And so what that means is that my A value is equal to 2. What about the ending here? Well, my graph goes 6 right here. That means to continue it, to keep the symmetry, I go another 6. I'm going to end over here at 12. So far we know the A, we know the B. I'm sorry, the A and the D. Let's talk about the C here. The C value is actually right here. My C value is 0 because I moved to the right 0. It's at 0, where it usually is. So I didn't move to the right at all. But the B value, we know that the total period of this from start to finish is going to look like this. That means the total period is this right here. It's 12. So 2 pi over B is equal to 12. We cross multiply, we get 12B is equal to 2 pi. We'll divide by 12. We get that pi over 6 is equal to my B value. There you go. We've got all of our values, A, B, C, and D. Now let's talk about something here. The shape of my graph, when we look at it, starts at a minimum down here and goes up and then comes back down. Now what shape is that? Is that a sine curve that looks something like this? Or is it a cosine curve that looks something like this? Okay. It's a cosine curve, but what's happened to it? Well, it's flipped over from what it's supposed to be. So what we're going to do is we're going to go ahead and create a sinusoidal function. We're going to put in the A, the B, and the C and D values, but we need to put a negative in there because that negative is going to cause a reflection in my graph to take place. Okay. Now I don't need that 0 that's right there, so I could just go ahead and simplify it and say pi over 6x and then plus 4. There you go. That's our function. It's not too bad. It's just a bunch of little details to kind of piece together, but pretty cool, huh? All right, let's talk about this one right here. It's a lot of words and a lot of little details, but it's really not too bad of a problem. And there's no graphing that we have to do, but I'm going to show you a graph just so we can understand what's happening. So it says one particular 4th of July in Galveston, Texas, high tide is going to occur at 9:36 a.m. Now think about what that means. That's giving me the highest point. That's giving me a maximum. And the maximum happens at 9:36 a.m. And it just happens to be that the water at that height or at that time is 2.7 meters deep. It then says that low tide occurs at 3:48 p.m., at which time the water was only 2.1 meters deep. So what they're giving me is a minimum of 2.1 meters at 3:48 p.m. Little fun fact, if you don't know this, the reason we have high tide and low tide twice a day is because what ends up happening is the moon is actually pulling on the earth. And as the earth rotates, you see the earth actually do this, and then it does this, and then does this, and then does this. And it goes high tide and low tide. And, you'd have to watch an animation to fully understand it, but that's the reason for our high tide and low tide. So let's continue on. It says that assume the depth of the water is a sinusoidal function of time with a period half of a lunar day. So let's see. Okay, I've got some times kind of slated across here. Let's talk about how I got all these. Okay, so starting at 9:36 a.m., we're going to go ahead and create a maximum at 2.7. Okay, and at some point later on in the information, it's going to be a minimum of 2.1. Okay, and it says at 3:48 p.m. Now think about what that means. That means it's starting right here, and it's going to go down to this time and then back up at a later time. Okay, so if I look at the graph for that, just remember that the graph is going to have a point here, and then here, 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 and here. So my graph is going like this, and we've got a minimum and we've got a maximum that's taking place there. And then in addition, we should actually recognize that this is going to happen on the other side as well, that we're going to have it go down and then come back up and continue over here. Okay? And so when we're looking at this, we have to figure out a few things. What are these times? Like, where do they come from? Well, if we remember, in between each one of our points, there's 1, 2, 3, 4 separate spots, right? Those 4 separate spots are called our interval. It's how we move as we go from point to point. Well, if the period of this is 12 hours and 24 minutes, if we break this period into 4 equal parts, 12 divided by 4 and 24 divided by 4, means that we're going to go in increments of 3 hours and 6 minutes as we move along this. So if I start at 9:36 and I add 3 hours and 6 minutes, I'm going to end up at 12:42 p.m. If I then add from here 3 hours and 6 minutes, I'm going to end up at 3:48 p.m. If I then add 3 hours and 6 minutes, I'm going to be at 6:54. And then if I add 3 hours and 6 minutes, I'm going to be at 10 p.m. Now I'm going to stop there because if I keep going, 3 more hours is going to put me into tomorrow. Okay. Let's go the other direction though. If I go minus 3 hours and 6 minutes, I'm at 6:30 a.m. Minus 3 hours and 6 minutes, I'm at 3:24 a.m. And then minus 3 hours and 6 minutes, I'm at 12:18 a.m. And if I go any further, I'm at yesterday. Okay. All right. One of the details I do want to mention to you is that in the homework, you'll see questions where it talks about time and it talks about things like 2 a.m. and then it talks about 2 p.m. If we're setting up a function, we can't use 2 for both of these. And so one of the things to recognize is that we have to use military time for anything after 12 p.m. So if I was to say like 1200, that means it's 12 p.m. 1300 is 1 p.m. 1400 is 2 p.m. 1500 is 3 p.m., and so on and so forth. The way that military time works is whatever the number is that's given to you. So if I was to say like 1800, all you do is subtract 12 from it, and that means that we're looking at 6 p.m. Okay, and if I was talking 2 a.m., you would just use 0200 or just the number 2. Okay, so 2 a.m. you use the number 2. 2 p.m. you would use the number 14. Okay, you're going to see that come up in the homework. All right, let's continue with the questions here. So we've got our whole graph. What we need is the middle, just so we know kind of what we're dealing with. So again, to find the middle of this, we'll take the average of 2.7 and 2.1, so add those together and divide by 2. We'll get 2.4. And now we're ready. Let's start analyzing all of our information. It says, at what time on the 4th of July did the first low tide occur? Well, low tide is right here. And if we follow that up, that happens at 3:24 a.m. Okay. At what was the approximate depth of the water at 6 a.m.? Well, 6:30 is right here at this spot. So if I go to 6 a.m., we're going to go just a little bit before this, and it's going to be right here. And what is that approximate depth? Well, it's fairly close to 2.4 right here. So I'm going to go ahead and say approximately 2.3. At 3 p.m., let's look at this. If this is 348, which is right here, at 3 p.m. is going to be just before it. It's going to be down here. And if I come back to it, it's going to be right here. And that's going to be just a little bit above 2.1, which means we're going to be at about 2.2 meters. Okay. What was the first time on the 4th of July when the water was 2.4 meters deep? Well, 2.4 meters is right here. We could see it happens right here, but it also happens before that right here, and that's at 12:18 a.m. There you go. All right, and the last question here. This is a fairly easy one to kind of piece together, but let's talk about it anyways. So what it says is let's identify the max and the min from all this data. Now this is temperatures throughout the year. So that kind of makes sense when you look at this, that the information goes up, gets warmer, and then it kind of goes back down. And so if I was to kind of plot a bunch of points for this, it's going to start down here and it's going to get warmer and then kind of come up and then go back down, right? Now this is a cosine function and this is not going to be exact. If we look at the difference between each month, there's like an 11 here, there's a 10 here, there's only a 4 here. There's a -1 here, so this is not going to be consistent. So what we're effectively looking at here is just a line of best fit, right? We're just creating an equation that we can use to kind of determine the information in the future, okay? So when we look at the maximum, we see the maximum happens right here, and then we see a minimum happens right here, okay? And so let's identify the maximum. We did. It's at 84 and 32. Let's throw this on here. As far as the midpoint of this goes, take the average of these. So let's add these two together and divide by 2. And you'll see we get 58. That's my vertical shift because my graph has shifted up 58 since it's not a 0 anymore. It's up at 58. Okay. As far as side to side goes, my graph does not start at 0 here. It actually has been offset and shifted to the right 1 when we first look at the data here. So my C is equal to 1 here. My amplitude for this is the difference between these two, so 84 minus 15, and that's going to be at positive 26, okay? Let's determine the period. The period for this, if we look at it, is over the course of 12 months. So let's determine the B value. 2 pi over B is equal to 12. 2 pi is equal to 12b, and that means that we have pi over 6. So it says construct a sinusoidal function for this. Well, you have to think about first, what are we dealing with here? Is it a sine or something else? This curve, when we look at it, is not your sine curve. Remember, sine looks actually like this, okay? This is actually a cosine curve. More importantly, it's a cosine curve that's been flipped over. And so what that means is that we're going to have y is equal to, there's going to be a negative here attached to a to reflect it over, negative 26 cosine. Pi over 6 is your B. It's shifted to the right one, and it's up 58. And that is it, okay? So now think about when we could see other situations like this. In the homework, you'll see one where it actually talks about a Ferris wheel. And so in this Ferris wheel, it talks about the highest point and the lowest point, and it talks about like what's taking place here. I don't know what it is. I'll just say 100 feet. I might be wrong, okay? And maybe it doesn't even say that. I think it might say the diameter. It might say the diameter is 50 feet. Okay. And what happens is this is like 5 feet off the ground. Okay. And so if I say, well, what's the maximum it gets to? If it's 5 feet off the ground and the diameter is 50, that means it gets to a maximum of 50. And then as it spins around, it comes back down, it gets to a minimum of 5. So we've got a maximum of 50 and a minimum of 5. And then it might say that what the period is. Well, the period, we can figure that detail out. We can figure out the midline of this by adding those two together and dividing by 2. And that's my up and down shift. And so you get the idea. We can use this kind of find pretty much anything that has a repeating pattern, a circular pattern taking place. Okay? So that's it, Mustangs. This concludes this lesson. It's not too bad. I know it went a little quick, but again, slow it down, go back, look at things at your pace, and you guys should have no problem doing this. Take care. Until next time, you guys be safe, be responsible. Don't forget to like and subscribe my channel, and have a great day.